We have an example problem here. It says, what is the equivalent resistance of this circuit? So this is a pretty involved circuit in terms of what we've been seeing, but we should be able to figure this out. So series and parallel all boils down to paths taken. Starting at the battery, going around, I must pass through the 4 ohm resistor. Once I do, I reach a junction. That means there is a choice. So the 4 ohm resistor is not directly in series with just one of these. It's directly in series with everything we're going to come upon. Now the simplest option would just to be go straight and down through this 24 ohm resistor, and then I see that I can get back to the battery. So that's one option. The other option after this 4 ohm resistor is to go down through the middle. I have to go through the 6 ohm resistor. Well, that gets me to another junction. That means I can either go through the 8 or through the 24. Either way, we get back down to this bottom wire that will get us back to the battery. So the 4 is not directly in series with any of these. We need to start where we lost choices. I don't know if that's the best way to say that. Ultimately, we must first combine the 8 and 24 here that are in parallel. The reason why, I cannot say this 24 and 6 are in parallel, because that would mean my path would take me through just the 6 or just the 24 and then get me back to the other side of the battery. That's not the case. So these are not in parallel just by themselves is what I mean. What is in parallel is everything between these two junctions. Because regardless of how, of how I go from that top junction to the bottom one, I could go this way, and then to here, or this way to here. Because I can go from the top junction to the bottom junction in 3 ways, I need to combine those ways together. So I want to first, in this one path where I must pass through the 6, I have a choice to travel through the 8 or the 4. And so I want to add those first. So I'm going to redraw our circuit. This 4 ohm resistor is still here. This 6 ohm resistor is still here. But I am coming up with an equivalent resistance for the 8 and 24 in series. And then this other 24 on the right-hand side is still the same 24. So our equivalent 8 and 24, in my mind, I think I might have said series. I apologize if I did. I know these 2 right here are in parallel. Consulting my test notes, in parallel, we have an inverse relationship. I'll write it symbolically first. So 1 over 8 plus 1 over 24. In this case, 24, that's 3, so 4 over 24. But again, with the inverse relationship, make sure you invert that. So this is going to be 6 ohms. Our equivalent over here is 6 ohms. So we're on our way still to finding an overall total equivalent resistance of the circuit. Even though I labeled this here as our equivalent, that was equivalent of only the 8 and 24 together. So we're not done with the equivalent resistance for the circuit as a whole. I'm going to go ahead and scroll up because I've redrawn our circuit. Again, following a path, I know I must pass through the 4, but then my choice is to go through the 6 and the 6, which will then take us back to the other end of the battery, or go down through the 24, which will get us back. I still cannot say the 24 is in parallel with just this top 6. It's everything between the top junction and the bottom junction that are in parallel. So what I want to do next is combine those two 6 ohm resistors in the middle together and treat them as if they were one. So this is another R equivalent. I'll call it R equivalent 2. R equivalent 2 is for the 6 ohm and 6 ohm in series. They're in series because if I choose to come through this middle branch, I must pass by both 6 ohm resistors. Consulting my test notes, when resistors are in series, I can simply add them up, the resistor values up. So 6 plus 6 is 12 ohms. Okay. So we're just simplifying this circuit on down. Now our path takes us through the 4 through 12 or through the 4 through 24. Between this junction and this junction, that's my choice. I can go through the 12 or the 24. So 12 and 24 ohms are in parallel. If I want to redraw the circuit, which I always do to make sure I am accounting for things properly, I still have the 4 ohm up here. This is an R equivalent 3. In parallel, we have the inverse relationship. So 1 over 12 plus 1 over 24. See, 24, 2, 3 over 24. But then we have to flip it. So R equivalent 3 will be 24 over 3. So 8 ohms. So in that messy original circuit, which I'm going to scroll up to it for just a second. I'll come back here. I erase all the writing here. What that is telling me is I could have, instead of putting all of these together the way they're connected, instead of doing that, I could have just put an 8 ohm resistor there in the first place, which I probably would have if I had one. This, of course, is just a practice finding these equivalent resistances. Similar to capacitors, you're not going to be able to find every single possible resistor out there, but you can combine them to get what you need. So again, following my path, these two are in series now. So to treat this as one circuit with one battery and one resistor, this overall equivalent resistance. In series, our equivalent is calculated by just simply adding. So 4 plus 8 is our 12 ohms. So the way those resistors were all connected in the original circuit is equivalent to having one resistor with a resistance of 12 ohms. Similar to capacitors, we could talk about the current. We would draw the current flowing from the positive end of the battery to the negative end. The current that would flow in this circuit would be the battery voltage over the equivalent voltage. That comes from delta V equals IR, but we know the battery voltage is across this resistor when it's the only resistor in the circuit. So if we wanted to know that, in this particular case, the current that would flow would be 2 amps. And of course, we could work our way back, which I'm not going to do. But in series, we would now know the current that flowed up here is 2 amps. Both of these would have 2 amps flowing through them because they have to have the same current, and it must be the same current as their equivalent. And then we could find voltage and take that back. So it would be very similar to what we did with capacitors. The difference is we have to use the equation that's applicable to resistors to work our way back.